Hello my dear students, in this particular problem we will understand how to find the radius at a particular point on a curve. So suppose you have a curve which looks like this. I have chosen the two axes, x-axis and y-axis. So this curve basically lies on the xy plane. Now if I consider a very small part of the curve ds, as you know a small part of a curve is a straight line. So that ds subtends, if I just draw the 2 points of the curve, they meet at this particular point. So it subtends some angle d theta at the center C of this circle. So basically what I can say that this ds is a part of this particular circle whose radius is capital R. Our goal is to determine this capital R, which we call it the radius of curvature. And this radius of curvature will vary from point to point on this curve. If I take a small element here, the value of radius of curvature that I will get here will be entirely different from the radius of curvature that we will be getting here. Okay. So if I want to find out what is the radius of curvature at this particular point maybe, then how we will do it for any curve? It's a very useful concept at the +2 level physics. So here you see, if I choose this particular part ds, it will have a corresponding height and a base of a right angle triangle. So I am considering a right angle triangle whose hypotenuse is this ds. So evidently the altitude will be dy and the base is dx. So what we can say using Pythagoras theorem, that ds square is equals to dx square plus dy square. So very clearly what we can say, that this ds is equals to under root of this one. So I can take dx. So it is basically under root of this one, dx whole square plus dy whole square. If I take dx square common and bring it outside, so I can say that ds is equals to dx times under root 1 plus dy dx whole square. So I got an expression for ds. Now this ds subtends some angle d theta here. So please understand that 360 degree means 2 pi radian. So for 2 pi radian you will move in the you will cover this entire circumference of the circle. So 2 pi radian covers 2 pi r distance. 1 radian will cover how much? 2 pi r by 2 pi. So 2 pi radian basically covers a distance 2 pi r, which is the radius of the circle. So 1 radian will cover how much? 2 pi r by 2 pi. And this d theta angle will cover how much? Simply unitary method, r d theta. So this r d theta is nothing but this ds. Alright. So r d theta is equals to ds. What is r? Radius of curvature of this circle. Okay, at this particular point. If I draw a circle with this particular part, r is the radius of curvature. So r d theta is ds. And what is ds? ds is this. Alright. So we can say from here, so 1 and 2, using these two I can say that r d theta is equals to dx times 1 plus dy dx whole square. So I can call this one as my equation 3. Now you see at this particular point, if I draw tangent, that tangent is the slope of the curve at that particular point. So that tangent makes some angle theta with the horizontal. So from here I can say that tan theta is equals to dy dx. Alright, tan theta is dy dx. So if I differentiate it, so what will I get? I will get sec square theta d theta d2y dx2. And what is sec square theta? 1 plus tan square theta. I am assuming that you know d2y dx2. d2y dx2 is ddx of dy dx. Now what is tan theta? Tan theta is dy dx. So what we can say? 1 plus dy dx whole square into d theta equals to d2y dx2. So very easily you can say that what is r d theta. Okay, so from here we can find out d theta. What is d theta? So therefore d theta can be written as d2y dx2 divided by 1 plus dy dx whole square of that. So this is my d theta. This is equation 4. Now I will use equation 4 in equation 3. So if I put 4 in 3, so from here I can say that r into d theta is this, d2y dx2 denominator 1 plus dy dx whole square is equals to dx, and here also you are getting 1 plus dy dx whole square, this whole to the power half. Okay, so from here we can say that r is this. Okay, r d theta means basically this. And what do we know? We know ds is equals to this, and ds is r d theta. Now what is our goal? Our goal is to find out the value of r. Okay, so how we can do that? Okay, our goal is to find out the value of r. Now here we basically differentiated with respect to x. That's why we got this. So sec square theta d theta dx we should write. Here also I can say d theta dx. Here also d theta dx, and here also d theta dx. So when I say d theta, that will be this multiplied by dx. So there should be a dx here. Okay, because here we are differentiating with respect to x. That's why d theta dx, not with respect to itself. So now I can cancel off this dx and dx. 1 by 1 plus dy dx whole square, and this is 1 plus dy dx whole square to the power half. So that if I cross multiply, it will be 1 plus dy dx whole to the power 3 by 2 divided by d2y dx2. So what is the radius of curvature at any particular point on the curve? So this can be written as 1 plus dy dx whole square, whole thing raised to the power 3 by 2 divided by d2y dx2. This is the radius of curvature at any particular point on a curve. So if you know a curve, if you go to a particular point, any particular point on that curve, at that point you have to find out the value of dy dx and also d2y dx2, and then you have to use it to find out the radius of curvature of the curve at that particular point. Okay. So basically that's the final result. Okay, so very important concept, that if you consider a curve, once again if I summarize, if you consider a curve and if you visit any particular point on the curve, each point on the curve can be represented as a part of a circle, and radius of that circle is the corresponding radius of curvature of that particular point. How do we find radius of curvature? First of all, at that particular point I will draw a tangent, and that tangent is making some angle with the positive direction of x-axis, which we are telling tan theta, and that is dy dx. And then I will see the rate of variation of that slope, because d2y dx2 represents that. The slope of the curve is dy dx. Okay, how that slope is changing its inclination, that is basically determined by d2y dx2. It is the rate of change of that slope dy dx. It is ddx of that dy dx. Okay, so at any particular point, if I can find out these two informations, I can very easily find out the radius of curvature of that particular point. It's a mathematical analysis, doesn't much have to do with physics, but it is a very important mathematical tool which finds immense application while solving several numerical problems of physics. If this particular concept is known, many numerical problems becomes very easy to solve. I hope it has cleared some fundamental concepts. Thank you everyone. Have a good day.